We're walking along the Pigeon River now. It divides the United States from Canada. It's pretty calm down here. You could imagine a canoe going along it, but in a short while it'll start to get much more uninviting.
In our previous video, we talked about the container, the list, and the stack ADT. Today we'll talk about the queue, the tree, the table, and the graph. The queue is the first one. It's basically a line. You put people in line, you enqueue, and you remove them, you dequeue them. First in is first out. So think of the start of a line to get into a movie or a restaurant or a concert. This is the first person in, and he'll be the first person out. This is the second person, and the third, and the fourth. They don't know much about social distancing, apparently, but we know that we'll always draw off the front of the line and bring people into the restaurant or whatever in that manner. Many data structures in computer science use queues, sending jobs to a printer, first in, first out. CN uses it, file streams use it, and there's lots of practical examples from the real world. Our next ADT is the Tree ADT. Now the tree is usually implemented with pointers. You make leaves on the tree and you get information from them. But the important part about the Tree ADT is that data goes in using an ordering principle. Usually it's something like less than left, greater than right. What that means in practice is something like this. The data is at the top of the slide. 45 is the first data value read, and so that goes into the tree first. Now the next data value that comes, 67, uses the ordering principle, less than left, greater than right. It's greater than 45, so we attach it to the tree in that way. The next value is a 12. It's less than 45, the root, and so it goes in to the left. The next is a value 7. Where does it go? Less than 45, less than 12. Off to the left. 8, less than 45, less than 12, greater than 7. Off to the right. And so on. The ordering principle, less than left, greater than right, applies with every data value that we have here. This is a good one to maybe pause and go through a couple times until you get the idea. Now, if the tree is distracting, we'll remove it because this looks more like what we're used to in computer science. Imagine now that you want to access all of this data and do something with it, like print it out. We'll try that here, and we'll use the ordering principle to our advantage. This tree is made up of a bunch of little subtrees. So what we'll do is we'll go down the left-hand side as far as we can and print the left subtree off first, then the root, and then the right. So we follow down the left as far as we can go, and we print out the value 2. That's the left. Then you go to the root, that's 7. Then you go to the right, and you print out 8. And now you've done that subtree. So now you go to its root, which is the value 12, and print that, and then off to the right, the value 39. And then once you've printed that, you've got that subtree, and you go to its root. That's the value 45. You print that off, and now you go to the right. We've done the left tree, we've done the root, now we're going down the right. Again as before, do the left subtree, so we go down to 52 and print that, and then the root, 67, and then the right, 94. And so in that manner, we've traversed the whole structure, printed everything out using our ordering principle. But notice this, the data all came out in sorted order. We didn't have to move anything around. This is somewhat miraculous. And it's something we can do with trees that we can't easily do with any other structure. There are lots of examples of trees in this world, but the sorting one is probably the best. Our next ADT is the Table ADT. This is used to represent two-dimensional arrays, things that have rows and columns. We insert and delete and retrieve from a table, and we're already used to this a little bit. We've seen two-dimensional arrays. You can also make an array of linked lists, and that would be a two-dimensional structure as well. There are table examples that come from the real world. Databases and spreadsheets are probably the easy ones, multi-dimensional problems. And then finally, our last ADT is the graph. Graphs can be implemented with arrays or pointers. You add and remove things, but here's the deal with a graph, and you could see how you'd really want to use pointers for this if you could. Every node in the graph might be connected to any other node in the graph, so it might need to have 2 or 3 or 4 or more pointers, establishing a relationship to that. Graph problems sometimes are called networks, and they're some of the thorniest problems in computer science. How do you manage local area networks, distributed resources, and so on? The founder of C++, Bjarne Stroustrup, used the C++ language when he invented it for precisely this type of problem, distributed networks. That's it for today. Thanks for watching.